Hi all, my name is Vishnu and I'm an S1 IT student from GCBH. So today I'm going to talk about blockchain technology, and my goal today is to give you all a very simple introduction on what blockchain technology is so that you get a general idea. Now, some of you might have already heard about blockchain at some point in your life, or you might have at least heard about it in the recent Indian Budget Union. So what is a blockchain? Well, before going to that, most people seem to confuse between blockchain and bitcoins. Now, bitcoins are basically a digital currency, whereas blockchain is a technology through which Bitcoin transactions can be achieved. Bitcoin was also the first widespread application of blockchain. Now, coming to blockchain, well, in simple words, blockchain is a decentralized, distributed, and oftentimes public or open digital ledger consisting of records called blocks that are used to record and track transactions across a computer network. Okay, now this might sound confusing, so let's try to understand what this means on a conceptual level. So let's take an example here. Consider person A who lives in Spain and another person B who lives in Japan. Now A wants to transfer some amount of money, let's say $10 to B. Now normally how he would do this would be like, he'll first send the money to a bank. The bank acts like a middleman in this transaction. The bank will take, let's say, $1 as charges and send the remaining $9 to the person B. Now the problem with this transaction is this process takes a lot of time, even days. You have to trust the third party, that is in this case the bank, with your valuable information. Third, it is less secure and your data is likely to be tampered. Now what blockchain technology aims to achieve is 1. To remove the third party so that you are actually transferring the money to the person you want directly. 2. To make the transaction way faster and cheaper. That is, the transaction happens in seconds and also it's cheaper compared to the charges the third party takes. 3. To make it more secure and open. Okay, so now let's dig deeper and find out how blockchains actually do this. So just like earlier, let's take another example here. Consider 4 persons A, B, C and D. Let's say at the beginning or at Genesis, A has $15. Now this information is stored in a block and it is usually known as Genesis block. And now suppose A transfers a small amount of money, let's say $10 to B. This transaction is also again stored as a block and it is linked to the Genesis block. B gives $7 to C and C gives $3 to D, and these transactions are also similarly stored. Now as you can see, all these transactions are stored as blocks and changed to their previous transaction. Hence the name blockchain. These blocks are basically a list of transactions that can be accessed by all the members of the network. Each member in the network can now see where the money is, how much money each person has, and can also validate a transaction. Now suppose A tries to transfer $15 to D. This transaction will not happen because D and the other members already know for fact that A has only $5 remaining because it started out with $15 and has already given $10 to B. In the definition of blockchain, at the beginning of my slide, I mentioned the word open ledger. Now basically this is what we call an open ledger, where ledger means nothing but a list or a collection of data. I also use the term distributed ledger. Now to make this ledger distributed, I'm going to make a small change in this flowchart. As you can see, now each member holds a copy of the ledger, hence the name distributed ledger. Now this gives us another problem. If a new transaction happens, let's say B transfers $2 to D, then this transaction should be added to all the copies of the ledger. Now who gets to add this block to the open ledger? Well, this is decided by a protocol in the blockchain network called consensus algorithm. Different blockchains use different consensus algorithm. For example, Bitcoins use proof of work algorithm. There are other consensus algorithms such as proof of stake, proof of capacity, proof of elapsed time, etc. Let's see how this is done. Consider the same example where B wants to transfer $2 to D. First, B will publish and broadcast an intended transaction, but it has not yet been validated. Now we introduce the principle of miners. Miners are special nodes in our system of network which has the power to add blocks to a ledger. There are many miners in a network. In our case, let's consider A and C as miners. Now these miners will compete against each other, and the first one to win will publish and broadcast the block to all the ledgers, and hence making the ledger synchronized. Now in order to win, the miner has to follow two things. First, it should validate the transaction. Here, the transaction is already a valid one because as we can see, B has already sufficient fund in its wallet. Second, the miner should guess a complex hash which should be equal to a unique key in the intended block. This requires a lot of time and computational power, and hence the first miner to solve the problem will be rewarded financially. After this, the miners will go on to solve another hash problem, hoping to get a reward the next time. Now this was just an example of the consensus algorithm used in Bitcoins. So in summary, key principles of a blockchain are: it should be decentralized, it should be open and a public ledger, it should be a distributed ledger. Blockchain technology is not just limited to cryptocurrencies. It has various other real-life use cases too. For example, in food safety, digital voting, storing digital IDs, data sharing, etc. So that's all for today. I hope all of you got a general idea about what is blockchain, its principles, and the problems blockchain attempts to solve. Lastly, I thank CSI GECBH for giving me such a wonderful opportunity to be a part of the Tech Talk series. Thank you.